Welcome to a new test and teardown video. This time I got two very interesting voltmeters. I think they are also very old, and it is a little bit special design. I think the meter is called a galvanometer. It is essentially just a mechanical meter like you know it, but it is specially made to be very sensitive. I don't know if we can see this. 0.0001 volt, and I don't know how many ohms is this. 30 ohms probably. I don't know how easy is that to read. There is a shorting wire here for transport. Somebody wrote a lot of notes. That's actually some sort of a formula. Why would people write all sorts of funny things here? But I need to clean this. This is super dirty. So before we can start playing with this one, I really need to clean it. We can hardly see the meter or read anything here. But it is really dirty. The other one I already cleaned. Let's see if we can. Yes, we can read this. That was a bit better picture. Ooh. And they are super sensitive to movement. And this is why we got this indicator here. See if I move it. Ooh. It goes crazy. I believe this mechanism up here, see when I turn this, I can move it probably back to 0. Ooh, way too much. So I need to be patient and move it really slow. It always goes too much. We got 3 feet. Let me lock this. So this one, when you dial this, see? Then it kind of locks the needle, and then it's locked for transport, I guess. Now we can see the feet, how they're made. It's really heavy. So it's standing on 3 points. One is fixed and the other 2 they're adjustable. So if we put this on a table and focus on this little air bubble here, so I can dial it in with a little bit of luck and skills. I don't know, it's difficult to do with one finger like this. It was a lot easier when I was using 2 hands. See, now using 2 hands it was a little bit, it's actually still not perfect. And it is super critical. Just a tiny little touch and it will go way out. So what I think is, I'll try and loosen this. So now it's free. And then I'll try and input a little bit of voltage and see how sensitive is this really. let's try and play a little bit. I got 1 ohm and 1 kilo ohm as a voltage divider. So that will give me a source impedance of 1 ohm, right? And a factor of 1,000 on my input. So now it's connected to this one. I cleaned the scale a little bit, and this should be my 0. Also, I adjusted this one a little bit. The funny thing is, the circle is not in the middle. Look at that. Only if you go down here or something. If you look from the top, the circle is not in the middle. That's weird. Anyways, let's play. So this is 0 volts. That is 1 volt. So that means 1 millivolt, right? All I have to do is wait and wait and wait for it to stable. Here on 30 bananas, whatever it is it's reading. Let me go back to 0 and see if it returns. All you have to do is wait a long time, and it will actually 0, I think. Isn't this just amazing? You can measure that low voltages with super high resolution. Wow. That is impressive. I can't wait to see how they've done this. Of course, I can dial this one carefully in to get it into perfect 0. But I mean, this is some science, deep science stuff that would have been really expensive. And look at the size. I don't know, there's maybe a spring or some stuff in here. I've got some, oh, the wood is cracking a little bit here. And again, this one is the release for the needle. Yep, see? And it goes like, and then it's stuck. So now it's free. And let me give it 1 millivolt in one direction. Let's see if we can. We know it's going to go to 30, right? So let's just go the other way. Is it exactly the same? I hope so. Otherwise it's because my 0 is not perfect, or we just don't wait a long enough time. So, and by the way, I tried exactly the same on this meter here, and I don't get anything at all. So maybe this one needs higher voltages. I am a little bit afraid of just cranking in like a lot more, so I think I will make another resistor divider. Maybe a factor of 10 more, see if I can see a little bit. I am lucky. The other one also works. So I changed the voltage divider to 100 ohms and 1 ohm. So that will be 70 millivolts. But look, I got a return to 0 kind of problem. Let's swap the wire, the voltage, and then there is. It's a little bit stuck in here, and then it goes positive, and then when I remove the voltage, it's not going back. It's like there's a mechanical hysteresis or something in here. See, then it's not moving so much. I'm gonna poke a little bit, and then it will move. And this also is probably the reason why this zeroing knob here is behaving. See? Really crazy. When I'm trying to move this, I can get it somewhere. I don't know, there's... Yeah, we need to kind of open and clean this. That's probably some rust or corrosion or some kind of stuff in there. So let's play a little bit with the little one first and see if we can figure out what is inside this thing. Because I need to open this and fix it anyway. I would imagine the main design idea of those two units, there will be very much the same kind of idea, right? Is it just those 4 screws and then we're in? There isn't really any other way, right? That was interesting. See, one of the connections, that's actually chassis. So that means they trust there will be an electrical connection via the screws. But the screws there are like full of old paint and stuff. So how is that reliable? That is just not a good idea. How's this metal so bent? That is weird. See? Ah, so you screw in those 3 screws and then you are really bad and violent with the other 2 screws to bend everything here to get this in perfect alignment. This is insanely crazy sensitive. See, this will bend and destroy. Wow. I would probably have lifted those a little bit first. I'll put in a little springy spacer. But no, let's run the front plate. And then we got some glue here, and that some of the glue actually dropped down here. That is not good. Oh, look at the corrosion here. Let's see if this... No, it's not. So that I need to clean. I think this is... maybe paper of some sort. So that will be our magnet. And the other connection to the meter is just touching the back side of that one. So that's probably a good enough connection. And then the meter itself is hanging, as you can see if I move it a little bit super freely. Let's see if we can get a little bit more light in there. Like that. So when you screw the... See, this is the transport screw. So it lifts the entire needle or the coil. So the idea is you just put it all the way down here and then it's perfectly fine. Ooh, it is actually affecting the... So that is probably the problem. This one is magnetic. Right? No, but something is. So in here there will be some sort of a spring. Ultra sensitive spring. Probably also a connection. Where's the other connection? we need 2 wires to the coil. So 1 wire goes to that one, and that goes down and is connected to the bottom part, which is this one where we kind of screw and stuff. See? So what is in this one? And how do I fix this annoying mechanical hysteresis problem? Not that easy. But look, it's just completely dangles around like that. Is that really good? Yeah. Let me see. I'm just so afraid of opening this one and then spit down. I got springs and stuff all over the place. Now I pulled it apart. Remember, I got a unit that just didn't work. Mechanical stress or mechanical hysteresis, all sorts of problems. So there was no other way. I had to pull it apart. But by doing so, you're going to break it. So this is what you can learn from this video, is how this is all assembled and how it works. So you don't pull it apart like I did, because you are never going to be able to assemble this again. So if you look at the top of the coil up here, this is the kind of the needle point where it's normally fixed in a normal meter, but here there was actually soldered a tiny thin wire. It is actually that one here. This piece of wire here is so thin you can hardly see it. I need really good glasses to see this. It is insanely thin, and it is flat, by the way. So there is like a little spring function from its rotation. So you can imagine this one is soldered on the tip of this one. So this wire is now inside this tube. So this part, this one was screwed all the way in. You can see here is a solder point where the other end is. So this one was then screwed all the way, so it was visible from the top. So this groove is where this little screw here, so it's almost like a set screw, but this one goes through the hole here in the side to kind of lock the adjustment in place. So if you pull this, you're of course not going to pull the wire, right? So to assemble this in reverse order, somebody was actually able to solder this thin wire to this point and to that one. While doing that, holding this somehow by using magic, I don't know, could you hold it like this? Could you then take this piece here and stick it through the hole, and then with some other kind of magic grab it on the top? But then on the top it will be down here, right? Now you need to hold it again using other kind of magic you don't have, and screw this in all the way to down here. I mean, the first kind of grab, if it is this high, almost, if it's like this, right, you could probably just, no, you cannot. Ah, man. So I am not able to figure out how to assemble this and hold this in position using some sort of a special tool that is kind of not there, right? And then screw this in But as long as I don't get, you know, a grip on the thread, and the thread is only all the way up. So that means this one must be this high, right? Now we'll grab the thread. Could I hold it here? Yeah, that is actually possible if I mark this somehow, so I know exactly the spot, and then grab this. When now I got it, put in a special screwdriver, as you see here, right? Put in a special screwdriver through this hole, hold this so it's not rotating, all right? Dial this all the way in until it is perfectly in there while this goes down here, right? And then it should be assembled. I don't know, man. 400 hours later. I'm actually trying to attempt this from the bottom, so I will perform this stunt here from the front. I already solder this tiny little wire, and I just put this in the very first little turn. So now I'm gonna stick this through here and see if there's anything left when this is all the way through. So where the heck is it? Amen. Why is this shit not sticking out? Not my lucky day today. Can you see this? I actually got it through by blowing through it. So look at the length that I got here. I think this is actually possible to hold this with one hand and solder that one with another hand, and then put this on here, and let me see if that is going to work. That was indeed very difficult, but I actually managed to get everything back here and aligned, and the mechanical hysteresis, or the magnetic kind of problem, I don't know, but it is still there. I've been trying, see, to give it signal, and it's not returning to the same point if I go from one side to the other side. See? So see now. There's also a thing about it's not always. See? Where is the bad connection? Is it here? Okay, now it works. And it's super sensitive. Just if I move my fingers here, that is enough just to see. Ooh, magic. So now I'm ready to assemble this and see if it is in like any better shape. I cleaned more or less half of the old glue away and added some new. The ground connection to the front plate here was really not good, so I cleaned that and assembled that one as well. And also you see paint on all 4 screws to the chassis here, and this is important to the 4 chassis screws. So what I did is I cleaned them a little bit. I think like 2 or 3 of them, a little bit more. So hopefully we're going to get a better ground connection around here, and probably it's going to work a little bit better. But I don't have any high hopes. I couldn't get those screws out, so I can't really clean this. I believe this is made of aluminum or something, and this is just a paper scale. I would have loved to clean this and refurbish it in some way, but I think the screws here, they're completely rusted into this metal. So if I try to unscrew them, they're probably gonna break. Well, at least I got the meter nicely cleaned up, and this scale is super beautiful and yeah, clean, so we can read stuff. But I don't know if you can see this. Maybe I should add a another cable so we can sit and play. Not so easy to see, is it? How about that? And then I take my wires like this, and see, and then when I remove it, it just stays. So this is a meter with kind of full memory effect. Isn't that just fantastic? If I dial down the current just a little bit, and let's see what happens now. Then there is no reaction. So if I crank up the current a little bit, and then suddenly I get full scale reaction. And this is a 5 milliamps or 5 millivolts. I'm in 1 ohm impedance, right? But see, that is just weird, and the other meter is absolutely not at all like that. That is the weirdest of the weirdest. Ooh. But anyway, let's lock it for transport just like that. Let's play a little bit more with the other one. Well, this is the bottom of the other one with the wooden base. I removed its bottom plate so we can have a look. So that will be, what have they done here? Oh, this is old. You see the wood is delaminating a little bit here. And here we can see the bottom. Let me move the camera a little bit. Yeah, like this. See? So this is the locking mechanism. When you lock this, you kind of push everything like this. So here there's a bottom spring. Here it's actually easy to see how it is made. The other one was actually also made a little bit like this, but the spring was not like this. It was a spiral in one layer. It was just impossible to see. And here the bottom part is isolated, so there's a wire for that. So this is a very good design, and this one really works. I don't think I dare to open this anymore than this, because oh, look at that, we got 2 screws up here, and that will be what is holding, or maybe also these, right? I am in a terrible zoom. So that will be the screws. Then I could probably take out the entire unit, but I think it is a bad idea. We have learned what this consists of and what is the basic idea. That means I can't clean up the inside of the glass in this one. I really would like to do that, but I'm so afraid this part here is going to be pulled up and broken. But of course there must be a way this entire part here is assembled. How did they do that? I see 2 screws here, and that's probably connected to this somehow, right? And I don't see any screws or anything here. Ooh, this one can be pulled up. Ooh, that's probably not a good idea. That was interesting, and this explains why there wasn't any effect. So this is the protector, the calibration protector cap. And here is the real adjustment. Ha ha, that was nice. Of course you need to loosen everything here before you lift up this entire system here. Ooh, scary, scary. Of course there was a way. This one is much more intelligent designed. So this little top screw, there was another little set screw here, and then the top screw can be removed without causing any kind of damage to anything here. And look, there's also a really good connection to this point. Even if you do turn it around, they made sure that there is a good connection, because that is, of course, what is feeding the coil. Look at the internal parts here. How beautiful is that? Really, really. And now, this is visible. Wow, that is beautiful. So now I can clean all this up, polish the wood, clean all this, and see here the internal parts. See, that was kind of glued or welded or something, but they kept the screws out here. So of course you can't fix those screws. And the glass, see how dirty that is? This is really why I wanted to open this, so I could clean this and make it nice. That is definitely some cool instrument. I'm happy I was able to open this and not destroy it. So to be able to clean up this area, and look at all that, it's so dirty. I had to remove the connections here, and they were really difficult to remove due to some corrosion or something in here. They kind of melted into the wood, so that was difficult. I believe there was once a resistor here. I also cleaned this plate a little bit. Now it's nice. That was a lot of work to get this far, but I also need to take this out, otherwise I can't fix the broken wood. See, this wood is in a terrible shape, so I'll see if I can fix this somehow. I got the whole unit out in one piece. This is going to be a challenge to assemble again, because those are loose, so they can adjust, so they allow for adjustment of the entire unit here. Look at that, it's a real glass mirror on the back. I mean, everything here is just top mechanical quality. Oh yeah, by the way, did you see the spring? The way that it goes forward and back again? Isn't that just cool? I don't know if you can see this, but there's actually a tiny little hole here. See? So there's a tiny little metal thing in here that I had to pull out. Now I could unscrew this, and now I'll be able to take this entire part of it out here, and that will be the rest. And now I can fix the wood. Just look at all the details. They've gone all the way with every little, okay, we need 2 screws here, and we need those little spacers here, and instead of just having this part machined with the right spacers in this piece, it's just all over this machine like that. So now we're out in my little dirty workshop. I'm gluing 1/2 today, and I guess in 1 or 2 days I'm going to glue the other side, and then I can continue with this. So after gluing everything together, I just sanded. So this is just the first sanding. I'm gonna go a little bit finer, and then I'm gonna add some varnish. See if I can make this nice and shiny again. Let's see. I think all this glue stuff actually worked. The wood is now in one piece again, so that is good. So after a little bit glue this together and adding a little bit of varnish and a little bit of sanding, I think I'm ready now to assemble this again. I still see a little bit of this bad coloring of the wood from all the years, but see, this is where I glued it together. It is really difficult to camouflage that. It was really bad here on the sides, and this was the other side where I glued it together, and this side held up a little bit better. I think this is a pretty good restoration. I also gave it one thin layer of varnish from the bottom side, just so the wood would be able to handle humidity and the next 100 years. So yeah, now I'm going to put in all the brass parts. Hopefully I will be able to figure this out and do it nice and careful and nice and correct. And look at all the fancy parts here. I saved everything real nice, and I cleaned up those real good. Hopefully it's not going to take too many hours to figure all this out. Oh yeah, did I show you the meter here when it's all the way out? I really think this part here looks so nice. I'm about to be done with all the reassembly after all the nice varnish. I think it looks really nice and good and beautiful. It is nice and shiny. So I think I will end this video and say thank you very much for watching. Please come again tomorrow for a new one.